Hello. Hello guys. Today we are studying a new point, capillary action. Okay. Before this, we are studying what is meant by capillary tube. Okay. Now, a capillary tube. What is by capillary tube? A tube having a bore. A tube having a bore which is approximately equal to, this is the bore, okay, or bore. This bore, a tube which having a fine bore, okay, approximately equal to 1 millimeter, approximately equal to 1 millimeter, and open at both the ends. So what is by capillary tube? A tube having fine bore which is approximately equal to 1 millimeter and open at both the ends. Open at both the ends. Such tube is known as capillary tube. Is known as capillary tube. Okay. See here, a tube having fine bore, which is approximately equal to 1 millimeter and open at both the ends. Such tube is known as capillary tube. As like this. Okay. Now, if one end of the capillary tube is deep in a liquid, okay, suppose this is a capillary tube and this is a flask which having a liquid, okay. Now suppose this liquid as a water, okay. Now see, if the one end of the capillary tube is deep in a liquid, suppose water is partially wet or completely wet. Suppose pure water is a completely wet the surface of the capillary. Pure water which wets the surface of the capillary, or water is partially wet the surface of a capillary. Okay. Then the level of a liquid in the capillary, the level of a liquid in the capillary is rises. See here, if the one end of the capillary tube is deep in a liquid, or as like water, the water partially wets the surface of a capillary, then the level of liquid in the capillary what is meant by capillarity? Now, what is meant by capillary action? What is meant by capillary action? Okay, understood what is meant by capillary tube? A tube having fine bore which is approximately equal to 1 millimeter and open at both the ends. Such tube is known as capillary tube. Okay. Now, what is meant by capillary action? The phenomenon of rise or falls of a liquid inside the capillary tube when it is deep in a liquid. Okay. Now see here. The phenomenon of rise or drop, rise or drop, like rise or falls, rise or falls of a liquid inside of a liquid inside the capillary tube, inside a capillary tube when it is deep in the liquid, when it is deep in the liquid. Such phenomenon is known as capillary action. See here, what is it by capillary tube? A tube having fine bore which is approximately equal to 1 millimeter and open at both the ends are known as capillary tube. What is it by capillarity? The phenomenon of rise, that means increase, or drops, that means falls, of a liquid inside a capillary tube, inside a capillary tube when it is deep in a liquid. Such phenomenon is known as capillary action. So, for example, blotting paper. For example, blotting paper. This blotting paper absorb ink. Blotting paper absorb ink. Clothes, rag, such water. बघा blotting paper घेतला. बरोबर आहे. तो काय केला इथं काय असेल ink असेल तर तो काय करतो ink absorb करायचं काम करतो. Okay, म्हणजे it is the action. This action is known as capillary action. Okay. Now, see here. Next point. Capillary fall. Capillary fall. Now see here. Next point, capillary fall. Now see here. This is. Let us consider a capillary tube. Let us consider a capillary tube. The one end of a capillary tube is deep in a liquid. Suppose a capillary tube. Let us consider a capillary tube. This capillary tube, the one end of this capillary tube is deep in a liquid. We take here liquid as a mercury. Okay. Now, if we take liquid as a mercury, okay, then this mercury mercury does not weighs the surface does not weighs the surface does not weighs the surface does not weight the surface of capillary tube does not weight the surface of capillary tube. Okay, now see here the shape of mercury meniscus. Now see here this capillary tube is deep, one end of the capillary tube is deep in mercury and one end is open. Okay, now see here the shape of mercury meniscus is convex. Okay, so shape of mercury meniscus is convex. Okay, now let us consider 4 points A, B, C, D. Focus on only this diagram. Now let us consider 4 point A, B, C, D. Okay, now point A is just above the convex surface and inside the capillary tube. Point A is just above convex surface, okay, just above convex surface and inside the capillary, okay. Now point B is just below the convex surface and inside the capillary. Now point B is just below convex surface, and inside the capillary. Okay, now point C. Now see the diagram. Point C. That point C is just above the plane surface. Point C is just above the plane surface and outside the capillary. Point C is just above the plane surface, and outside the capillary. Now see point D. Point D is just below the plane surface, and outside the capillary. Okay. See here, let us consider a glass vessel. In this glass vessel, it contains a liquid as like a mercury. This mercury does not weight the surface of liquid. This mercury does not weight the surface of capillary tube. Let us consider, see here, the meniscus of above the convex surface, above the convex surface and above the convex surface and inside the capillary. Inside the capillary. Point B is just below the convex surface and inside the capillary. Point C is just above the plane surface and outside the capillary. Point D is just below the plane surface and outside the capillary tube. Okay. Now see here, let PA, PB, PC and PD be the pressures at point, be the pressures at point A, B, C and D. Okay, at point A, B, C, D. Okay. Now see here, the pressure on the concave side is always greater than the convex side. Now see here, pressure on concave side, pressure on concave side is greater than convex side, is greater than convex side. Now see here, point A is above the convex surface, that means the pressure at point A is PA. Point B is below the convex surface, that means the pressure at point B is PB. Now see here, the pressure on concave side, this is the concave side, pressure on concave side is always greater than convex side. So therefore we can write PB is greater than PA, PB is greater than PA. Okay. Now see point A and C. Now see point A and C, both the points are at same level. Both the points are at the same level. The pressure on the both of these is same. Point A and C. Point A and C are at same level. So pressure also same. Pressure also same. Therefore we can write PA is equal to PC. PA is equal to PC. Now the point C and D. Now between the point C and D, in the surface is plane. The point, so now point C and D, the surface is plane. So the pressure is same. So we can write PC is equal to PD. So PC is equal to PA. So we can write is equal to PA. Okay. Now therefore the PB is greater than PD. Now see here. So this is equation number 1. This is equation number 2, 3, 4. Okay. But the point B and D have the same horizontal level. In order to maintain same pressure in order to maintain same pressure, okay, same pressure, the mercury in the capillary rushes out the capillary tube, and because of this the level in the capillary tube is false. Now see here, बघा परत एकदा सांगतो, सोपं आहे. मी काय करते, एक ग्लास वेसल घेतला, ओके, ही माझी कॅपिलरी ट्यूब आहे. What is the capillary tube? A capillary tube having a fine bore which is open at both the ends, which is open at both the ends. Okay. Now I can take a liquid in this glass vessel as a mercury, and I dip this capillary tube, or the one end of the capillary tube is dipped in this liquid, that is mercury. Now mercury does not wet the surface of capillary tube. So the meniscus of mercury is convex. Okay. Now let us suppose there are 4 points A, B, C, D. Now point A is situated just above the convex surface and inside the capillary. Now point B is just below the convex surface and inside the capillary. Now point C is just above the plane surface and outside the capillary. Similarly, point D is just below the plane surface and outside the capillary. Okay. Now let PA, PB, PC and PD be the pressures at point A, B, C, D. Okay. Now pressures, we know that the pressure on concave side is always greater than convex side. So A is in convex side, PB is in concave side. So from this we can write the pressure on concave side is always greater than convex side. Therefore PB is greater than PA. Now point A and C. The point A and C are at the same level. So the pressure is same, that is atmospheric pressure. Okay, that is atmospheric pressure. Therefore PA is equal to PC. Now see here, point C and D. Okay, point C and D, the surface is plane surface, so the pressure is same. So we can write PC is equal to PB is equal to PA. Therefore PB is greater than PD. Okay. Now why in order to maintain same pressure, the mercury in the capillary rushes out of the capillary to maintain the same pressure. बघा इथं प्रेशर काय करायचं आहे, सेम मेंटेन करण्यासाठी कॅपिलरी काय करते, टू रशेस द मर्क्युरी आउटसाइड, म्हणजे काय करते, प्रेशर करते. इथं तुमची काय होते बघा, द लेवल ऑफ मर्क्युरी इन द कॅपिलरी ट्यूब इज डिक्रीजेस. ओके, सो now we are seeing next article, that is rise, expression for rise or falls of capillary. There are two methods. First one is by using forces, okay, and second one is using pressure difference. Okay, now first we see by using the force. Now let us consider a glass vessel. Okay, in this glass vessel in a liquid. So see here, here is the concave, the shape of meniscus is concave. Okay. Now let T be the surface tension of liquid. Let T be the surface tension. Let T be the surface tension of a liquid. Okay. Now let R be the radius of capillary tube. Okay. Now here see here is the T cos theta, where T cos theta is the vertical component. T cos theta is the vertical component of tension. Vertical component of tension, which is directed in upward direction. Vertical component of tension directed in upward direction. Now see here is the T sin theta. T sin theta is the horizontal component. Of tension acting radially outward. Okay. Now V is the volume of a liquid. V is the volume of liquid column. Okay. Now see here the total vertical component or the total vertical upward force acting on a liquid inside the capillary is. Now first of all we have to find the circumference. We have to find the circumference of meniscus. That is circumference is equal to 2 pi r. Therefore the total vertical upward force, acting on a liquid, column inside the capillary. Inside the capillary is the vertical component into circumference. It is vertical component is T cos theta inside the capillary tube is T cos theta into circumference. Okay. Now let M be the mass of a liquid. M be the mass of a liquid. Let rho is the density of liquid. Okay. Now the weight. Now we have to find the weight. Weight W is equal to mg. Okay. Now see here, mg according to the formula of density, density is equal to mass upon volume. Therefore, since mass is equal to density into volume, so I can write as the density into volume can be written as area into height. Suppose this is the height of a liquid rise in a capillary tube. Okay. Now we get M is equal to density into area pi r square h. Okay. Substituting this value in this equation, so we get weight is equal to rho into pi r square h into g. Calling as equation number 2. That is, weight means it is a gravitational force. Gravitational force. Okay. Now total upward force is equal to total downward force. So we get total upward force is equal to total downward force. Okay. So from equation 1 and 2, total upward force is T cos theta into 2 pi r is equal to total downward force from equation 2, rho into pi r square h into g. Okay. So from this pi get cancel, r. Okay. So T cos theta into 2 is equal to rho into r h into g. Okay. Now we want to find the value of T. So we get T is equal to r h rho g upon 2 cos theta. T is equal to r h rho g upon 2 cos theta. Okay. From this equation we also find the value of h. Okay. So value of h, therefore h is equal to 2t cos theta upon r rho g. From this equation, so this is equation number 3, this is equation number 4. From this equation we can say that 2 is constant, the tension is constant, angle theta is constant, density also constant. That means h is inversely proportional to radius and density. Acceleration due to gravity is also constant. Okay. So we can take a pure water. Okay. So suppose we can take an example. Suppose we can take a pure water. So then angle theta is equal to 0 degree. Then angle theta is equal to 0 degree and density is 1 gram per centimeter cube. So the tension is So this is the first method by using the force. Now see here, we can take a glass flask. In this glass flask, we are taking a liquid as a water. One end of a capillary tube is dipped in this liquid, so the meniscus is concave. Now let T is the surface tension of a liquid, R is the radius of capillary tube, T cos theta is the vertical component of tension directed in upward direction, T sin theta is the tension, T sin theta is the horizontal component of a tension acting radically outward, V is the volume of liquid volume. Okay. Now see here, the circumference of a layer is 2 pi r. Therefore, the total vertical upward force acting on a liquid volume inside the capillary is T cos theta into 2 pi r. Okay. Now m is the mass of a liquid, rho is the density of a liquid. So we want to find the weight. Weight is equal to m into g. Density is equal to mass upon volume. Therefore, mass is equal to density into volume. This volume can be written as A into h, where h is the height of a liquid rises in a capillary tube. Okay. So we get m. Substituting the value of m in this equation, we get weight W is equal to rho into pi r square h into g, which is equal to gravitational force. Now the total upward force is equal to total downward force. Substituting these values, we get the formula for T. From this equation, we also get the formula for h. So if from this equation T is constant, theta is also constant, acceleration due to gravity also constant, therefore height of a liquid or rises of a liquid is inversely proportional to radius and density. For example, we are taking a water and theta is equal to 0 degree and density is 1 gram per centimeter cube. So we get tension is equal to RH G upon